Hello friends, in this video we will look at a C program to design and run a stack. We will be designing the push and the pop functions which we will use to insert values into the stack and pop out the values. So in stack the insertion is known as push operation and the deletion is known as the pop operation. Apart from that we will design a display function which will be used to print the values on the screen. So stack, as we all know, is a last in first out type of arrangement in which whatever will be inserted into the stack will be extracted in the order of last in first out. So whatever is the last element that will be popped out first. In this we will be writing the C program and alongside I will be discussing the algorithm also. So let us begin. So first of all we need to include, since I am writing a C program, you have to save the file with the .c extension. I have named it stack.c and then I am including the stdio and conion.h files. These are used for including the C library files and they contain the declaration for various functions. Then what are the things that I need to do here in this program? First of all, I need to define the stack in the top variable. So stack will be an array. I'm not designing using a linked list but using an array. And top variable is an integer variable which will be pointing to the location where I can make an insertion into the stack. The next thing that I have to do is pop function. We have to define the pop function. Then we have to define the push function. And then we have to design the display function and one main is required in order to execute. So these are the different parts of the program. So let us begin with defining the stack in the top. So what we will do is we will say int stack. I'm using capitals for the stack, so let me use small case, there's no harm. And I have to define the size of the stack. Now as we know that in C language we cannot take a value from the user and then define the size. So what we will do is we will use a macro and we will define max size as 5 so that the stack can contain at most 5 values. And I will use this macro definition with the stack variable. Then I will define the top and top is initially going to be -1. -1 means the stack does not contain any values in the beginning. So anytime top is equal to -1 means that the stack is empty. Then we have to define the pop function. Pop function means that I am going to extract the value from the stack and return it to the user for further use. So what I have to do is I have to read what is there on the stack. On top of the stack, read the top of stack and then I have to decrement top by 1 so that that value is removed from the stack. And before all this, before I can actually perform a read operation on the stack, I have to check for the underflow that if some value is there on the stack only then I can read it. So the condition is if top is equal to -1, then we will print the message to the user that printf and we will put a message stack is empty. So we cannot read anything from the stack and we will simply return with failure. So I am returning a -1 for failure. Otherwise what I am going to do is I am going to read from the top of the stack. So I need a variable into which I can read the top of the stack. So I will declare int item and what I will do for reading is I will put here item is equal to the value on the top of the stack. So I will say stack top. So whatever value is there on the top of the stack that will be placed into the item. And then I am going to decrement the value of top by 1. So I will use the decrement operation. And finally, I will return the value that I have read from the stack. So I will return item. So if I am going to return a -1, that means I could not perform the read operation. Otherwise, I could remove an item from the stack, and I am returning that item as an answer to the calling function. So this is the declaration for the pop. It includes the underflow checking, then reading the value from the stack, and decrementing the value of top by 1. 3 operations are there within the pop operation. Now we come to the push function. Again, the push function, we will return the status whether we have been successful or not, and we are going to receive one item from the user that is to be inserted into the stack. That value has to be received from the user. So what we are going to do is, first of all, we will check for the overflow. Why we need to check the overflow? If the stack is full, then we cannot make an insertion, and therefore we should report to the user that the stack is already full. So overflow needs to be checked. If overflow is not there, then we will increment the value of top. So we will increment top by 1, and then after incrementing the value of top by 1, we will place the item on stack, and then we will return with success. So these are the operations which we have to perform in the push. So for overflow, the condition is if top plus 1 is equal to max. If we are pointing towards the last element of the array, in that case we cannot make further insertions because incrementing the top will make it equal to max, which is not allowed. So we will printf here. We will print a message to the user that overflow has occurred, and then we will return with failure, that is we will return with the value of -1. Now in case it is not the top of the stack, in that case we will increment the value of top by 1, and then we will place the item on the stack. So for that, what we are going to do is we will say stack at top is equal to item. So whatever item is passed by the user, we will place that on the top of the stack, and then we will return 0, which is success. So this is the push function, this is the pop function, and now we come to the display function. So we have to display the values on the stack, and for this what we are going to do is we will use a variable I for reading from the index for looping into the values of the stack, and then we'll say for I is equal to 0, and then I less than equal to top, then I plus plus. I'm going to printf the value on the stack. So I will put a tab in order to make it look neat. So /t is used for tabs, and then I will write stack of I, so that the value at the ith position is printed, and I will print a friendly message that /n status of stack. And so, and one more thing I can do here is I can check if top is equal to -1, then I can simply print that stack is empty. Right, and I put a comma here, and I just return with a failure. So for return with failure, I am going to make use of return -1. And if it is not the failure, I will print the stack, and after printing the values on the stack, I will return with success. So for success, I am going to return a 0. So we have written all the 3 functions for the stack: push, pop, and the display function. So let us just see if they are compiling fine. So okay, I have misplaced the comma here, so comma will come out. Okay, that's a typo. Again, we will execute and compile so that we know if there are some errors. Okay, I put a dot here. that's again a typo, and again execute, compile. So okay, there are no problems in this code. It is compiling successfully. That means syntactical mistakes are not there. Now we will design the main function. So again int main is there, and we'll put the round parenthesis, and then we will first return 0 for return of success. We'll place a gauge so that at the end it will stop for us. In Turbo C you need to use gauge. If you're using Dev C++, then you don't need to use gauge because automatically the software will provide for it. Now I will call push. Okay. First of all, what I'm going to do is I will initialize top as -1. Then I will call push with a value of 1. Okay. So initially if I try to pop, it should give me an error that it is an underflow. Then I push the value of 1, and then again I pop, so it should return the value of whatever is there on the stack. So it should return that value. So I will use it in printf. So printf, and to say the value on stack is, and I'm going to put %d here and pop, and then comma bracket, and I will put /n so that it appears in a new line. The value popped from stack is this. So what I will do is after push I will call display to display the status of the stack. Then I will printf, I will pop a value, then I will again push, I will push 2, okay, then I will push again 3, then I will push 4, then I will push 5, then I will push 6. Let us see what happens. If we are pushing more, then it will tell us. Then I will use display with each push. So let me put display over here. So check the status of the stack, and in the end we will pop. So this is the program. After 6 I have introduced a display, then I am again pushing a value of 7. So this trying to insert a value of 7 should display a overflow message, and then we will pop, and then we will see the contents of the stack. So let us execute. First we will compile. So it is compiling with success, and then we will run the program. So as we can see, first we have, let us match this with the main. So first we have tried to pop. So it is saying stack is empty. Then we say push 1. So status of the stack is 1. So using the display we are able to print this value. Then we say the value popped from the stack is 1. So 1 is popped from the stack. Now again we push 2, then 3, then 4, then 5, then 6. So 0, 1, 2, 3, 4. The stack size is 5. That means 5 elements have been inserted, and as we can see the status, the stack includes 2, 3, 4, 5 and 6. So that has been displayed. Now we try to push 7. For that overflow message is shown here. Then we display the stack. After a pop we display the stack. So after the pop 6 is removed and 2, 3, 4, 5 is displayed on the screen. So as we can see that the output is matching with what we have given the commands in the main program. I hope this video is helpful to you, and do subscribe to the channel and mention in the comments whatever you like, and if you dislike you can mention that as well. So thank you very much.